Hello friends, welcome to EC Academy. In this lecture, let us understand a very important topic in VLSI design, which is Introduction to Circuit Characterization and Performance Estimation. Now let us understand one simple question. What is circuit characterization? Circuit characterization means studying a circuit carefully to know how it behaves. We study how fast it works, how much power it uses, and how reliable it is. Without understanding the circuit characterization, we cannot design a very good VLSI chip. So you need to remember, the circuit characterization means studying the behavior of the circuit carefully. So a good circuit have small delay and low power consumption. Now you need to remember these key points before understanding this topic. First, the MOS structure is made by combining multiple layers. The MOS devices has gate, source and drain regions. Every layer of MOS device has resistance and capacitance. Inductance is ignored while doing basic analysis. We establish a signal delay and power dissipation. And these models helps us in understanding, improving and optimizing the MOS circuits. Now let us understand the MOS structure. A MOS structure is made by placing many different layers one above the other. These layers include conducting materials, insulating material and transistor forming materials. And here each layer has its own job. When all these layers are placed together, they form MOS devices. So you need to remember, the MOS structure is made by combining many layers together. Now let us look at the second important point. A conventional silicon gate MOS device has two important regions. The first one is gate forming region and the second one is the source and drain forming region. These regions include diffusion, polysilicon and metal layers. And there is an insulating layer that is separating these unwanted regions. So you need to remember, the MOS device has gate region and a source and drain region which is separated by a insulating region. So here gate region and source drain regions are two major parts in a MOS transistor. Now we come to a very important concept. Every layer has resistance and capacitance. Resistance opposes the flow of current and capacitance stores electric charge. These two properties decide how well the circuit performs. If resistance becomes high, signals become slow. If capacitance becomes high, charging and discharging takes more time. Because of this, the circuit becomes slower. So you need to remember, resistance slows the current and capacitance stores the charge. Again, resistance and capacitance together decides the speed of the circuit. So this is very important point to remember. Now let us understand the inductive characteristics. Every layer has inductive characteristics, but in basic circuit analysis, their effect is very small. So for simplicity, we ignore the inductance. This makes our calculations very easier. So you need to remember, we ignore the effect of inductance in the MOS transistor for simplicity. So you need to remember, the inductance is present, but for simple analysis, we ignore the inductance. So we focus on resistance and capacitance only. Therefore, in today's discussion, we mainly focus only on resistance and capacitance. Now we come to another important point. We develop a simple model to estimate key performance metrics. The two key performance metrics are signal delay and power dissipation. So what is signal delay? Signal delay is the time taken by a signal to travel from one point to another point. So signal delay is the time taken by a signal to travel from one point to another point. So what is power dissipation? It is amount of electric power used by the circuit. Every designer want less delay and low power. So the power dissipation is the amount of electrical power used by the circuit. So every designer wants less delay and less power consumption that will give better performance. So you need to remember a good circuit has small delay and low power make the circuit better. Now let us understand the important areas we study. There are 6 major areas. We'll understand one by one. The first key area is resistance and capacitance calculations. Every MOS layer has its own resistance and its own capacitance. These values affect signal quality and circuit speed. High resistance or higher capacitance can reduce the performance. So you need to remember every MOS layer has its own resistance and capacitance. And these values will directly affect the signal quality and circuit speed. Now let us understand the delay. Delay mainly comes because of RC, which is a time constant. Here, R means resistance and C means capacitance. When resistance and capacitance increase, delay also increases. That is why delay estimation is very important for high speed circuits. So you need to remember higher RC means higher delay. So this is very important. If resistance or capacitance increases, the signal becomes slower and there will be a high delay. Now let us look at the conductor size for power and clock distribution. Here conductor carries the power and clock signal. If conductor is very thin, the power loss become higher. If conductor size is proper, the power reaches every part of the circuit correctly. So, proper conductor size reduces power loss and minimizes signal integrity. Similarly, good clock distribution reduces clock skew and keeps all part of the circuit working together. So you need to remember proper conductor size reduces power loss and improves the signal quality, and also it has good clock distribution which helps in synchronization between different circuits. Now let us study power consumption. Power consumption has two parts. First is a dynamic power, the second is a static power. Both are very important. Modern VLSI chip aims to reduce both because less power means less heat, longer battery life and better efficiency. So you need to remember power consumption has two parts, dynamic power and static power. And reducing these two types of power improves the circuit performance. Now let us understand charge storage. MOS capacitor store electric charges. These stored charges help us during logic switching and memory operations. Without charge storage, digital circuits cannot operate correctly. So you need to remember MOS capacitors store charges, and these stored charges are very much helpful during logical operations and memory operations. Finally, let us study the effect of scaling the transistor. Today, the transistors are becoming smaller and smaller. When the size becomes smaller, the resistance changes and capacitance changes, and power consumption also changes. Scaling improves the speed, but it also creates new design challenges. Therefore, engineers must carefully consider these effects while designing the transistors. So you need to remember, smaller device changes the resistance, capacitance and power, and it improves the speed but creates new design challenges. Hence, the circuit requires careful design. Now let us quickly revise the today's class. MOS structure has multiple layers. Gate and source drain are the two major regions. Layers have resistance and capacitance. Inductance is ignored in a basic analysis. Signal delay and power dissipations are the key matrices. Models helps in understanding and optimizing MOS circuits. We studied resistance and capacitance calculations. We understood delay estimation using RC concept. We understood capacitor sizing for power and clock. We studied dynamic and static power. We understood charge storage in MOS capacitors. And finally, we understood how scaling changes circuit behavior. This is about introduction to circuit characterization and performance estimation. I hope you have understood the topic. Thank you.